Good morning, my lovely Math 8 people. We are here again with some more math. We've got lesson 1-9. We're going to do one solution, no solution, infinite solution, part 1. All right, so just because you've got an equation, it doesn't mean that you actually have an answer to that equation. So when we're solving, there are two steps that we're going to really pay attention to, because in these two steps, combining like terms and balancing, it is possible for our variables to completely disappear. They will cancel each other out. The coefficient will end up being 0. For instance, if we've got something like 2x minus 2x plus 3 equals 5. Okay, so in this one, in the combining like terms step, the 2x and the negative 2x, that becomes 0x, or nothing. And we end up with 3 equals 5. So the variables have completely canceled out in the process. In the balancing variables situation, what can happen on these ones is maybe we'll have, I'll just do the same example, 2x plus 3 equals 2x plus 5. So for balancing this one, we'd go, okay, I'm going to subtract 2x here, subtract 2x here. Same thing, the variables have canceled each other out. The coefficient is 0, and we end up with 3 equals 5. Our answer is not 3, our answer is not 5, it's neither of those answers. So these are a special situation where you may get no solution, or you may get an infinite number of solutions. So if the variables are removed, so if we end up canceling in the combining like terms step, or if we end up canceling out our variables in the balancing step, if they're removed and the statement you're left with is true, such as 2 equals 2. Okay, if your statement is true, then the answer is infinite solutions. Now here's what infinite solutions means. It means no matter what number you plug in for x in the original equation, no matter what number, you will get a working equation. You can plug in 2, you can plug in negative 50, you can plug in 537. All of these answers will work. It means any number you plug in will work for the equation. However, in these two examples here, we were left with a false statement. 3 never equals 5. The variables have been removed, and this is a false statement. What this indicates to us is that there are no solutions at all for the equation. There is not a single value that you can plug in for x that is going to make this equation work, to make it balance out. One solution is what we've been doing. One solution means there is a solution, and here it is. Okay, so let's look and see how this works out for us. I got a few examples here, kind of a short lesson. So first example, we are going to draw a line down the middle. Let's do blue. Going to draw a line down the middle there because we're good people. Okay, we're going to start with our solving process. We're going to distribute first. Nothing crazy going on here. So we distribute. We end up with 10x. Negative 2 times 3 is negative 6x. No, it's just negative 6. Negative 2 times 5x is negative 10x. Equals negative 6. All right, first step, distributing done. Let's combine like terms. This is one of our danger steps that we're going to look at. So we do have like terms. We've got 10x and negative 10x over here. 10x minus 10x is 0 x's. If I have 10 x's and I take away 10 x's, I have no x's at all. I have 0 x's. So these are gone. I'm left with negative 6 equals negative 6. So the variables have been removed. So this means I'm in a situation where I might get no solution or infinite numbers of solutions. So I check to see if the answer is true or false. Does -6 equal -6? Yes, of course it does. So my answer is there are an infinite number of solutions, infinitely many solutions, or we can just write infinite solutions. So what does this mean? It means in the original equation, I could have plugged in 1. If I plugged in 1, here I would have gotten 3 plus 5 is 8. 8 times -2 is -16. 10 minus 16 is -6. So if I plug in 1, that equation works. Can I plug in other numbers? Sure, let's plug in 0. If I plug in 0, 3 plus 5 times 0, so that's 3 plus 0 is 3. 3 times -2 is -6. And over here, 10 times 0 is 0. 0 minus 6 is still -6. 0 worked and 1 worked. And I can keep on doing that all day long. I can keep on plugging in numbers, and I'm going to get the same exact answer. It's going to work every single time. So that's what infinite solutions means. It means I can keep on plugging in numbers, and the equation just magically works every single time. All right, so in that one, we saw during the combining like terms phase of the solving process that the variables canceled, and we're left with the true statement. Let's look at the next one. On this one, we're going to start with our distributive property. We distribute 3, and on the other side, we distribute 9. So 3 times 6x is 18x. 3 times -12 is -36. 9 times 2 is 18x. 9 times -5 is -45. Step 1 done. Step 2, combine like terms. No like terms here, no like terms there. Move on. Step 3, balancing variables. I have variables over here. I got variables over here. I need to balance. So I'm going to subtract 18x from both sides. So 18x minus 18x is 0. 18x minus 18x is 0. I am left with -36 equals -45. Aha, so I've done the balancing of variables, and my variables have canceled out. So the variables have been removed. Is this statement true, or is this statement false? Does -36 equal -45? No, never. So this indicates to me that there is no solution to this equation. Which means no matter what number I plug in for x, this equation is never going to work. I mean, look at this. 18x minus 36, 18x minus 45. We've got the same value here and different values here. There's no way that's going to balance out ever. So there's no solution for that one. Number 3. So we're going to draw a little line right there. So for this one, remember we're going to distribute a -1. We get 3x minus 5 minus 6x equals 3x minus 5. First step, done. Next step, combine like terms. On this side, I do have like terms, the 3x and the -6x. So let's combine those two together. So I get -3x minus 5 equals 3x minus 5. Okay. Next step, balance. Subtract 3x, subtract 3x. These 3 x's have canceled. These 3 x's have not canceled. -3 minus 3 is not 0. -3 minus 3 is -6x. So I still have an x. I have not removed my variables. So this is telling me it's not infinite solutions. It's not no solutions. I have a solution here. So I need to keep going to find that solution because my variables have not been removed. They haven't canceled each other out through our properties of equality. So I'm going to keep on solving this. I'm going to do the addition property of equality and add 5 to both sides. That leaves me with these canceling there, so I get negative 6x equals negative 5 plus 5 is 0. Okay, again, this is not no solution. I still have a variable. If you have a variable, you have a solution. So I'm going to keep going. This is negative 6 times x, so I'm going to use the division property of equality and divide by negative 6. Now, what is 0 divided by negative 6? Well, it's 0. So I get x is equal to 0. Just because it says 0 doesn't mean no solution. It means the solution is 0. 0 works for the equation. 0 is okay as an answer. Let's plug it in just to show that this works. Okay, so I'm going to do 3 instead of x. I'm going to plug in 0. And then minus 5 plus 6 instead of x. I'm going to plug in 0. Equals 3 times x, and instead of x, I'm going to plug in, you guessed it, 0. And then minus 5. All right, 3 times 0, what's that? Oh, it's 0, that's gone. Okay, so negative 5. And then 6 times 0, oh, that's 0 again. 3 times 0, that's 0. 5 plus 0 is still 5. And remember, this is a negative 1 sitting out here. Negative 1 times 5 is negative 5. This equation works. When I plugged in 0, it gave me a true statement. Negative 5 equals negative 5. Therefore, 0 was my answer. That's one solution. So this one had infinite solutions. This one had no solution. This gave me one solution. And that one solution was the number 0. 0 was my solution. Remember, infinite solutions, no solutions, the variables cancel out. If you get one solution, you'll still have a variable in your final answer. All right, that's all the math I got for you today. See you next time. Bye-bye.